Okay, here's the Chapter 6 area multiple choice questions. Should be pretty quick. There's only 8 of them, I believe. Alright, calculate the approximate area of this shaded region in the figure by using the trapezoid rule using divisions at x equals 4/3 and 5/3. So that's 3 divisions like that. Alright, let's see if we can set that up. Since we have an interval that's 1 wide and we're dividing into 3, the width of each trapezoid would be 1/3, and that's, remember, we divide that by 2 because because of the area formula, which is 1/2 the height times the sum of the bases, right? It depends. Sometimes we think of it as the average of the bases, but here we put the 2 on the outside. So there's the height, there's the 2. Now, each one of our trapezoids, this end point is going to get used once, 1, and then the 2 in the middle will be used twice. So that's going to be 4/3 squared, 16/9, plus 5/3 squared, it's 25/9, plus the last y coordinate is 4, right? These two get doubled because they're playing the role of one side of this trapezoid and also then the left side of the other. So I just have to simplify that. That's 1/6 times 5, that's 1 plus 4. Let's see, 16 plus 25 is 41, times 2 is 82 over 9. I'm liking this answer with the 54ths, right? 5 with a denominator of 9 would be 45/9, right? That's the same as 5. It's 82/9, and 45 plus 82 is 127. 6 times 9 is 54, so liking that. Fun without your calculator. Alright. How do we do this? Well, that's you need to understand what that looks like. This is the absolute value function shifted to the right 1 unit. So instead of having the point of the v right here, it's shifted to the right 1 unit. So we're talking about this area. That's a 1 by 1 triangle, 1/2 base times height. And this is a 2 by 2 triangle, 1/2 base times height. That's 1/2 plus 2, 2.5 or 5/2. And while we're at it, let's see this one. This is the, I think it might be the same problem basically. This is the same thing shifted over 3. 1, 2, 3. Now the point is here. We want the area from 1 to 4. And you can see it's actually just a mirror image of the same area. This has an area of 1/2, this has an area of 2. That's basically the same question. It's the same shapes. Let f be, those are from different years by the way, funny enough, so I guess they liked that question. Let f be a continuous function, and the value of the function is trapped between 2 and 4. Then the greatest possible value of this integral, or this area, would be, well, if we want to make the area as big as possible, then I think we would want to max the function out, right? So we'd squeeze it up to its upper limit. So that'd be the area from 0 to 2, and if we push it all the way up to 4, I mean, that's as big as the function could be, right? So if it were that big, it would be a 2 by 4 rectangle. So it would have an area of 8. Excuse me. And likewise, the smallest it could be, if we push it all the way down to its lowest limit, right, then it would be a 2 by 2 square, then it would be 4. So we know that this expression, if this is true, if it's always in between 2 and 4, then that would have to be between 4 and 8. All right, this looks familiar. We know how to do this. So if we want the area from 1 to 3, we could do the area from 1 to 10 minus the area from 3 to 10. That would give us that area, right? The area from 1 to 10, and then subtract off 3 to 10. It'll just leave you the 1 to 3 part. Very geometric, I think, that. So let's see, 1 to 10 is 4 minus 10 to 3 is 7, so 3 to 10 would be negative 7. So 4 minus negative 7, that's 11. You got to be careful with that double negative. Is negative 3 there? Oh, it is. Of course, that should be an 11. That should be an E, which is the first letter of the word 11. Okay. 3 equal subdivisions of this, so that means the divisions are at negative 4 to negative 2 to 0 to 2, right? That's how you chop that up into 3 equal pieces. And what is the trapezoidal approximation of this? Well, let's see. Each trapezoid is 2 wide over 2 times, then let's see, the first one, when we plug that, that would be e to the 4th over 2, right? Plus 2 times the middle ones, that would be e squared over 2. I plug 0 in here, I get 1/2. Plus, if I plug the 2 in, I get e to the negative 2 over 2. So the 2 over 2 cancels out. Let's see if this looks like any of our candidates here. Those 2's would cancel out, so let's just rewrite this for a second here. It looks like e to the 4th over 2 plus e squared plus 1, which is, these have e to the zeros in them, so I'm going to write that as e to the 0, plus e negative 2 over 2. It's always a good idea to look at the answers. So that's not that or that. It's close to this, but this looks like it's missing the 1/2. And it looks like this is actually equivalent, right? Because the 1/2, if you distribute it, it would cancel those and might get the same thing here. So that's another E, which stands in this one for Euler, not for 11. Right? You know who Euler is? He's the dude that E is named for. All right. If f is a function such that the derivative exists for all x, and the function is always greater than 0 for all x, which of the following is not necessarily true? Would the area from negative 1 to 1 under the function have to be greater than 0? Well, I think if the function's always above, then as long as we're going in the right order here with negative 1 and 1, I think that's got to be positive area, right? Because it's always positive. So I think this is true. And we're looking for not necessarily true, so let's get that out of there. Is it true that you can take a 2 on the inside to the outside? That's actually true for any function, right? It doesn't have to be positive or have the derivative exist. That's always true. Let's see. Does the derivative from negative 1 to 1, right, whatever the function looks like, we know that it's positive, right? It's some positive function. does the derivative from -1 to 1 have to be twice as big as here to here? I don't think so. It certainly doesn't look like it in my picture, right? That doesn't look like it's twice as big as, or sorry, it's not half of the whole thing. In other words, for this to be true, I think this would have to be the same size, right? For the whole thing to be equal to 2 of those. And I guess that would happen if it was an even function, right? If it happened to be an even function, then you'd have that right kind of symmetry for this. So this one does not look good for being true. So I think that this looks like it would be the answer. But let's check the other ones just to be sure. If you go from -1 to 1, do you get the same area as -1? Yeah, that's true for all integrals, right? That's like this one. It's just a property of integrals. And so is this. This is like your integral notes. -1 to 1 is equal to -1 to 0 plus 0 to 1. That's always true. So funny enough, the only one that depended on this information that they gave us was the first one. And this is the one that's not true, or not necessarily true. Now let's see, how about this? Well, you need to recognize that functions of this form, remember that the top half of the unit circle looks like this, and in general, this is what the top half of a circle looks like with a radius of r. So this is the top half of the circle centered at the origin with the radius of 2. And we want the area from 0 to 2 of that. So that's a quarter circle. That's a quarter of pi r squared. And that's 1/4 of 4, so that's just pi. Oops, which is C. Ta-da!